So today we're going to look at a logarithmic function as an inverse of an exponential function. So this is our first introduction into logarithms and logarithmic functions. So let's look at our objectives. How can we write a logarithmic expression, particularly if we are given an exponential expression or function? And then second, what does it mean to evaluate a logarithm? So let's start with the definition of a logarithm. We'll jump right into it here. So notice the first part of the definition is a exponential function, y equals b to the x. Okay, so if we have that expression, that function, then we can rewrite it as a logarithmic function. And notice the log has three elements to it. It has a log and then a small b in the subscript. Y equals x. Now, the way you would say this in words is the log of base b of y equals x. Okay, let's figure out how this works. So here's our exponential expression, y equals b to the x. Yeah, we don't have an a value in here. We're going to keep it really simple, right? The a value would be 1. So notice when we rewrite it as a logarithm, in our exponential function, right, the y value that we're finding when we raise b to the x is what we're taking the log of, right? So we're taking the log of y. The b is the base, right? So each logarithm has to have a specific base, okay? Whatever the base is in the exponential form is also the base in the logarithmic form. And then when we take the log of y, we're actually finding the exponent, x, okay? Anytime we're taking the log of something, we're basically finding the exponent. What is the exponent? It's the exponent that we're raising the base by in order to get the value of y. Okay, so a little confusing, but as we get through some examples here, I think it'll start to make sense, okay? So here's a way we would say that in words, right? What do you get when you raise b to the x power? Well, we get y, right? If we rewrite it in a logarithm, we're asking a different question. What exponent do you apply to the base b in order to get y? Okay, so they're the same three values, same three variables, but we're just kind of asking the question in an inverse manner. Okay, so logarithm, if you one thing you remember about a logarithm, when we take the logarithm of a number, we're finding the exponent that we would raise the base by to get that number. All right, let's look at an example. Here's a very simple exponential expression, right? 25 equals 5 squared. No one's going to argue with that, right? We know 5 squared is 25, okay? So if we want to rewrite this in logarithmic form, what would it look like, right? So the base is 5. Let me get my pen here to notate this. The base is 5, right? Here's our base right here. So this becomes the base of our logarithm, okay? Y becomes the number we're taking the log of, and our exponent 2 is what the log is going to be equal to, okay? So in some ways, it's just kind of rearranging the three variables, the three values from their exponential form to the logarithmic form. All right. Let's do a little practice here. See if you can just do this in your notebook. Rewrite these in logarithmic form. So here's the first one. 8 equals 2 to the third power. So you can pause it, write it, and then keep it going to see if you got the correct answer. Here it is. Our base is 2. We're taking the log of 8, and the exponent is 3. So 2 raised to the third power gives us 8. That's what that logarithm is telling us. Here's another one. 16 to the 1/2 equals 4. Remember, raising something to the 1/2 power is the same as taking the square root. So our base is 16. So log base 16 of 4 is 1/2. Remember, we're trying to rewrite a logarithm. So we're asking the question, what is the exponent that I raise the base by to get the y value, what I'm taking the log of? All right, let's do another one. 10 squared equals 100. So log base 10 of 100 equals 2. Now, let's go the other way. I'm going to give you a logarithmic expression. Can you rewrite it in exponential form? So let's just take this one step by step here for the first time. So when we want to write it in exponential form, the first thing to do would be, what is our base, right? So I'm going to put that over here. I'm going to say a base becomes my base here. Remember, the 2 is the exponent, so it's going to be 2 squared and then equals, right, what we're taking the logarithm of. So that becomes 36. Okay, so I just showed you step by step. Let me clear this and then go ahead and show the answer here. All right, let's try another one. Log base 64 of 8 equals 1/2. All right, 64 to the 1/2 equals 8. And let's throw some variables in here. Log base y of x equals 8. So this would be a base of y raised to the 8th power gives us x. Okay, so there you have it. How we can write either exponential into a logarithmic function or form, or take a logarithm and rewrite it in its exponential form. Now, there's something called a common logarithm. So this is a logarithm that has a base of 10. So if it has a base of 10, and this is actually a very common base for logarithms, especially in terms of where we apply logarithms to the real world, especially in science, we often use a base of 10. So when we're writing a logarithm that has a base 10, we can call it a common logarithm, and we don't need to put the 10 there. Notice there is no 10 here, right? We just leave it blank. So if it has no base, you can assume that the base is 10, and we would call that a common logarithm. So let's do a couple examples here where we have a common log. So 1,000 equals 10 to the 3rd. Our base is going to be 10, so we can just write that as common log of 1,000 equals 3. Let's try another one. This time I've given you the common log. Can you write it in exponential form? So it doesn't say, but we can assume if there's no base, then it's common log. So 10 to the 2nd power, right, gives us 100. Okay, so that's what a common log is. Now, if you look on your calculator, there are really just 2 types of logarithms that your calculator can calculate for you. And one of them is a common log. So sometimes it just says log, sometimes it'll say log with a little 10 underneath there. That's the common log. So that's the one that you would use if you're taking the common log of a number using your calculator. All right, the second part of this lesson is, what does it mean to evaluate a logarithm? So evaluating means that we're trying to find the exponent, right? What is the log equal to? So everything we've done so far, we've always been given all 3 values, or we've just treated them as variables with a letter as a placeholder. But now we want to actually say, what is, in this example, log base 9 of 81? So remember, the question we're really asking is 9 raised to what power gives us 81? Now this one's pretty straightforward, right? We know that 9 squared gives us 81, so x would equal 2 in this example. But sometimes it's not always so obvious, right? And we need a little bit of method to evaluate a logarithm. So How do we do that? The first step is we're going to rewrite this in exponential form. So we're going to write 81 equals 9 to the x. Okay, so it still is clear what are we trying to find, right? We're trying to find the exponent. But let's say we didn't know that 9 squared equals 81. What could we do next? The second step is to write each side using a common base. So we already have 9 as the base for the right-hand side of the equation. What could we use for the left-hand side? Well, 81 is 9 squared. So we're going to rewrite 81 as 9 to the second power. Now, again, this is a very simple example. You'll see a couple other examples where this process is much more helpful, not quite so obvious. But here's the thing. Once we have it written with a common base, then if these two values are equal to each other, then we know that the exponents have to be equal to each other, right? So if 9 squared equals 9 to the x power, then we know that the 2 has to be equal to the x in order for overall expressions to be equal. So now we can write basically a new equation that sets the exponents equal to each other, and we get our solution of x equals 2. Okay, we knew that from the beginning, but I gave you the steps here for evaluating a logarithm. All right, let's try a couple of these together here, okay? So we have log base 5 of 125 equals x, and we're going to follow the process, even if you can do the mental math, okay? So first we write it in exponential form. 125 equals 5 to the x. Now we're going to rewrite each side using a common base. So 125 could be 5 times 5 times 5. So that's 5 to the third, and therefore x has to be equal to 3. Okay, pretty straightforward. Again, we could have done that one with mental math. But let's try this one here. Log of 64, log base 64 of 4 equals x. Okay, so let's work through that. We have 4 equals 64 to the x. Now we want to rewrite with a common base. So 4, right, we could write as 4 to the first power. 64 we can write as 4 to the third power. But notice we also are raising the whole thing by x. So we got to be a little careful here, but this is where the process really becomes useful to us, right? Because this one's not quite so clear mentally what we would do. So what happens when we raise one power by another power? We're going to multiply those exponents. So we're going to multiply the 3 and the x together. So we get this, 4 to the first on one side and 4 to the 3x on the other. So now we're going to set those two exponents equal to each other. We get 1 equals 3x, very simple equation to solve now, and we get x equals 1/3. Now, what is that telling us? It says if we raise 64 to the 1/3 power, we get 4. Now, does that make sense? What does it mean to raise something to the 1/3 power? Right? Let's write this out here a little bit and just prove it to ourselves. So we have 64 to the 1/3 power equals 4. Does that make sense? Now, remember, when we have a rational exponent, we can rewrite this in radical form, right? So the 3 becomes our index. So now, really what we're saying is the cube root of 64, 4. And the answer is yes, okay? So it's kind of good to look back here and just prove that the answer that we got makes sense on this. All right, let's try a couple more of these and then we'll wrap this up. So log 9 of 27 equals x. See if you can work through this. Go ahead and pause it. Okay, here we go. So exponential form, 27 equals 9 to the x. So this time we're going to use 3 as our base for each side, right? We can take 27 and raise 3 to the third power. 9, we could raise 3 to the second power. So again, we're going to multiply the 2 and the x on the right side and now set the exponents equal to each other. So we get 3 equals 2x or x equals 3 halves. Okay, and I'm going to do the same thing here. Does that answer make sense? How did we get 3/2? So what we're saying, right, is 27 raised to the 3/2 power equals, oops, not 27, I'm sorry, 9 equals 27. So let's rewrite this, right, in radical form. So it's going to be square root of 9 raised to the 3rd power equals 27. Does that make sense? Yeah, square root of 9 is 3. 3 to the 3rd power is 27. Okay. All right, let's try one more here. Log base 8 of 16 equals x. Go ahead and pause it, work through it, and then we'll do it together. Okay, here we go. Write it in exponential form. Now we have a 16 and an 8. What could we use as our common base? We could use 2, right? 2 to the 4th is 16. 2 to the 3rd is 8. So we're going to multiply the 3 and the x, and now set those equal to each other, right? So we wind up with an answer of 4/3. Now, does that make sense? Let's just check it one more time here, because I want you to see how this all fits together, right, with what we know about logarithms, exponential functions, and radical expressions. So what this is telling us is 8 raised to the 4/3 power should give us 16. So let's write this as a radical. So cube root of 8 raised to the 4th power equals 16. Does that make sense? Yes. Cube root of 8 is 2, right? And 2 to the 4th is 16. Okay, so it works. All right, let's clear all of this. A couple more here. Log base 4 of 32 equals x. Okay, here we go. I'm just going to step through. I'm not going to describe. Okay, so we get 5/2. We take 4, raise it to the 5th power, and then take the square root, we would get 32. Here's the last one. Log base 12 of 12 equals x. Now this one, take a look at it. 12 to what power gives us 12? Right? We don't have to actually think too hard, but let's go through the process. We're going to use 12 as our common base, raise each side by the 1st power, and we get 1. That makes sense, right? 12 to the 1st power gives us 12. All right, that's it. So we know how to write logarithmic expressions from an exponential expression, or go the other direction, write the exponential expression from the logarithmic expression. And we know what it means to evaluate a logarithm. All right, that's it for today.